new part of the worksheet. Okay. So we are on number 10. So this one, you're starting with moles of one thing and you're going to volume of the same thing. So if you look at our chart here, so we're going from moles of one thing to volume of the same thing. And I know that it's aqueous because I'm given a molarity. Okay, so that's just going to be 2 steps. Okay. I'm going to put my 0.8 moles right here. Okay. And then I know this 2 molar can be 2 moles per 1 liter or 1 liter per 2 moles. So in this situation, we want to use this one because we want our moles on the bottom. So we'll put 1 liter on the top and 2 moles on the bottom. And that's going to equal 0.4 liters. It does say in milliliters. And so if it's 0.4 liters, we would move our decimal place 1, 2, 3 places, and that would actually become 400 milliliters. Okay. Now you can do this problem a little differently. You can use molarity equals moles over liters just because it's just one compound. And you would just plug in 2 for molar. You would plug in 0.8 for molar or for moles. And then you'd put X on the bottom and solve for X. So you'd get the same answer, just 2 different ways to do the same problem. Okay. 11 and 12 are homework. Number 13, you are starting with moles and you're going to volume. This is going to be of a different compound. Okay. So we're starting with moles and we're going to liters of a different compound. So that's going to be 1, 2, 3 steps. Okay. So I'm going to start with 4.5 moles right here. Okay. That's of carbon dioxide, CO2. And then I need to get to moles of propane. So I'm going to put blank moles over blank moles. So this one's going to be a CO2 on the bottom. And then since we're going to propane, that's going to go on the top. So propane's coefficient is 1 and carbon dioxide's is 3. Okay, so 3 on the bottom. And then I just need to go to my volume using my molarity of 1. So this is going to be 1 mole per 1 liter or 1 liter per 1 mole. So we want to use this one, right? It wouldn't really matter because it's just 1 over 1. But anyway, we want the mole at the bottom. So 1 liter per 1 mole, and then you'll be good to go. So if you divide that up for number 13, you would get 1.5 liters. And if you convert that to milliliters, 1, 2, 3, that would equal 1,500 milliliters. Okay. Number 14, you start with 0.4 moles of propane, and it's the same, it just says this correspond to. So it's really just the same thing. It's the same compound as before. So it's just a 2-step problem then. So we have 0.4 moles. Okay. And then we're going to change our molarity into 2 moles per 1 liter or 1 liter per 2 moles. We want to use this one on the right-hand side, so our moles cancel. So we have 1 liter per 2 moles. Okay. And then that's just going to equal 0.2 liters. You could do this one again. This is the same compound if molarity equals moles over liters, right? You could plug in the moles, you could plug in the molarity and solve for that. You'd still get the same answer. Okay. Last one, number 15. So you're starting with moles of one compound and you're going to milliliters of a different compound. So if you look on your chart here, you're going 1, 2, 3, and I'm going to aqueous because I'm given a molarity. And this one is going to be 3 moles, okay, and that's CO2. And then I'm going to propane, so I know I have 1 mole of propane for every 3 moles of CO2. And then I'm going to be using my molarity, okay, so I'm going to say for every 1 liter, I have 0.750 moles, right? That's how I got that from this molarity, okay? And if I divide that all up for number 15, I'm going to get 1.3 liters. And if I convert that to milliliters, move the decimal place 1, 2, 3 spots, that's going to be 1,333 milliliters. Okay. For these last ones, these are the density ones, and good luck with those. I might put the answers in the group chat. We'll see. Okay. Good job.